This is a question where we have to look upon the symmetry of the circuit along with the flow of current. The problem is somewhat like this. There is a slab of conducting material which is extending to infinite distances in all the direction, and one face is defined, right? And on this face, he has marked a square here. He has marked a square of edge length A. And at a point A on the circuit, the input current I naught. And from point B, the current is coming out. That value is also I naught, right? Now, this material has got a resistivity rho, which is the unknown in the problem. And the setter has said that the potential difference between 2 points C and D on this plane. So if you connect an ideal voltmeter between C and D, he notes a potential difference of capital V between those 2 points. So remember, I naught is a given data for you. V is known for you. A, the edge length of the square, that is also given. Resistivity rho is the unknown parameter. And remember, all these dimensions, this side, upside, inside, outside, or the left side, all these arrows, material is tending up to infinity. So quickly, I will just tell you, this problem is based on principle of superposition here, right? So what I'll do is, there are two things. I mean, first of all, I'll try to distribute current from A and assume that B is absent. So current will be distributed uniformly. And while this distribution happens, actually the current spreads in the form of hemispherical wavefronts. So if you look into that material, it will expand out like hemispheres, right? So if I only look into the effect of A, then with respect to A, if I draw a hemisphere within the conducting material of radius r, my J as function of r should be I naught upon 2 pi r square. And that helps me out because this becomes 1 upon rho into E as function of r. So my E comes out as rho I naught upon 2 pi r square. And then it becomes simple because if you look into the potential drop which he has measured, basically D is on a hemisphere which has got a small radius of A, and C is on a hemisphere of radius A root 2. A root 2, and this guy is A root 2. So my point is, you multiply this by dr, and try to integrate it from r is equal to A to r is equal to A root 2. So just integrate it. This value from A to A root 2, we talk about the potential drop between D and C. So this will become Vd minus Vc in this problem. So this is only the effect of A, remember. So it is rho I naught upon 2 pi and minus 1 upon r. So 1 upon A minus 1 upon A root 2. Now my statement is that when you start looking into effect of B also, forget A now. Now you're talking about elimination. I mean, the current coming out from B and coming from infinity up to B. So it will come also like hemispherical wavefronts. It will come inside like hemispheres. Same result will hold. And again, when this time, when it will come inside, D will have a higher radius. So D will have a higher potential. Then C will have a lower potential. So Vd minus Vc is still positive. So because of B also, the effect remains the same. So that means the V that he has given through an ideal voltmeter is actually Vd minus Vc ka net value, and that net value is twice of this value. So I think this is quite simple. Rho I naught upon pi into 1 upon A minus 1 upon A root 2, and just equate this value with V. So if you look into this expression, the only unknown in this problem is now rho sulfur. The thing is, a much more better or beautiful combination of this problem comes from the next data. So I'll use the same fundamental directly in the next problem. Now here the problem is a bit changed. Now I've got a sheet which is having a small thickness, that thickness is T, and it is expanding up to infinity in 2 dimensions, right? This small thickness is T. There are 2 points A. This side is 2D, right? This is 2D, and this is also 2D. So D, 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 D. So what I do, I supply current from point A on the sheet, and I extract current from point B on the sheet, I. I don't know how it is scattering on the sheet, but finally, I provide a voltmeter, ideal voltmeter between C and D here, and it notices a voltage of V. So if V is given, I is given, T is given, and D is given, can you again find out the resistivity of this slab? And again, it is infinite in 2 dimensions. So now again, I will try to solve it directly in 1-2 line. Now the problem is, here the problem was having a symmetry which was like hemispherical wave fronts which are expanding. Here in this problem, the wave fronts will be cylindrical. These are like cylindrical wave fronts which will expand. Now the problem with this question is, I don't know the distribution of current right now on this sheet. And still the cylindrical wave fronts cannot be accepted till there is full symmetry. So for full symmetry to be activated, what I will do, I'll connect 3 more half sheets. It's like first quadrant, second quadrant, third and fourth quadrant, so that it becomes a complete infinite sheet. And now I will take 2 special points, the image of A here, right? A image, B image. Try to understand what I'm doing. And instead of A, I will presume that somebody is supplying 2I from here. Somebody is extracting 2I from here. Somebody is supplying 2I from A ka image also. And somebody is extracting 2I from B ka image also. Now what happens is, I got 4 points from 2I is supplied. From 2 points, 2I has been extracted. The good thing is, for every individual 2I, now there is cylindrical symmetry. This cylindrical wavefront symmetry is there for every 2I, individual 2I. That is for A, for B, for AI, for BI. Because now I have an infinite sheet. It's like a small rod of height T. It will scatter up to infinity. And the good thing is, if I do this, this section remains same. I mean, because of this 2I, the physics of the problem in second quadrant has not changed. 2I scattering in both the sides. You got it now? And 2I, so partially first, second, and here also first and fourth, and elimination from B and elimination of current from B image. So the physics of the second quadrant remains the same. But there is cylindrical symmetry. And now by virtue of cylindrical symmetry, if I have to write VC minus VD, try to understand, you have to write this thing because of 4 people. Because of A, because of B, because of AI, because of BI. I'm just writing it because of A. Now directly tell me, if I want to write the field now, and there is cylindrical symmetry. So at R, if I want to write J as function of R, that should be equal to the current. The current is 2I now. So it is 2I upon 2 pi RL, and L is T, the cylindrical curved surface area. So 2 will cancel out. It is this thing. And J is 1 upon rho into E. So basically, E as function of R is rho I upon pi RT. Just take care of this function. Now it's a 2-line problem. So what will I do? Now just look into the polarity also. If the current is scattering from A between C and D, remember I am writing VC minus VD. This is V and this is the net value. And let me write one by one. So I'll integrate this. This will become rho I upon pi T. right? I'll multiply by dr. So ln r, and r I will integrate from d to d root 5. Remember, this distance is d here, and this distance here will be d root 5. So the radius of the cylinder will change from d to d root 5. So ln root 5 is one effect. Good. If you look into the effect because of B, this will remain the same. So I'll take twice. Try to understand. When you talk about B and you take the current 2I to be coming inside towards B cylindrically, so D point is there and C point is there. Now C is at a distance of D root 5, and that is high potential, and D is at a distance of D, that is low potential. So again, VC is greater than VD. That's why I've taken 2. And 2 more people. Now, this 2 is because of the other 2 people. Those 2 guys are, who are the AI and BI. Now, try to understand, from AI, if I start drawing cylinders, I'll get the same integral. Now, the first radius will be that of D, and the second will be of C. Now, the distance of C from this guy, that is 3D. And the distance of D from this guy is D root 5. So, I mean, again, there is a difference. The current will keep on moving outwards. And now D will be at a higher potential because it is at a lower distance. So, I have to take a minus sign. It should be negative. And the term should be rho I upon pi t. It is ln of, try to understand, this is d root 5 is 3. So ln of 3 by root 5. 3 by root 5. And the last guy, minus because I have to take VC minus VD. And the last guy is BI. If you look into the effect of BI at C and D, and current is coming in, so D will be at higher potential and C will be at lower inside. So VC minus VD will be negative. Same thing. Now you are ready with your solution. Just use log properties and separate rho, you'll get your answer. So both the questions are based on the geometry or the symmetry, and they are identical ideas to solve, right? So that liquid has got a resistivity rho, has got a dielectric constant of epsilon r, and the distance between the plates is d. Now he says that if you take a charge particle here at t is equal to 0 and leave it from state of rest, supplying it a charge of q naught, there is no gravity, right? And there is a drag force from the fluid, that is beta into v. So the question is, if you leave this charge particle at rest, how much distance, maximum distance, will this particle move before coming to a state of rest? Right, maximum distance it will move before coming to a state of rest. We will also observe one thing, that after coming to a state of rest, will it stay there or it will come back? We'll see that. Don't worry. Question is clear, right? So the point is simple. As you leave this charge particle here, we understand that in this complete medium, we have got a uniform field, which is actually V upon D, right? And there is this force Q naught into E, which pulls this rightward. So after some time, T is equal to T, acquires this velocity V, and obviously, if this position is X is equal to 0, now he is sitting at a position X is equal to X, general position, right? Now the good or the bad thing is, this charge particle will have a charge which is also a function of time, because charge will consistently leak from the surface of the conductor, that wall, right? Because of the RC properties of the medium. And if this is the case, then there will be a force QT into E. E is V by D, and there will be a drag, which is beta small v. Remember, this small v and capital V are different. So my simple point is, the net force which is acting is QT, voltage upon D, minus the drag, which is beta V, and that should be equal to mass, small m, into dV of the particle upon dt. That should be my first equation, right? Now, let me try to write q as function of time directly. There is a property in RC circuits that you give me any conductor of any shape, right? And from the surface of conductor till infinity, you fill a medium with resistivity rho or conductivity sigma. Then the RC of that conductor with infinity, I mean, any surface you give me, right? Any conducting surface, and we are discussing its nature with infinity. Whatever medium we have filled here, if there is a resistivity and epsilon naught is present, epsilon r is given, then this property all of us understand that the product of RC of this medium is always rho epsilon naught epsilon r. I'll prove it also, don't worry. I need not prove it again and again for different shapes. This is a standard property which is independent of the shape of the conductor. The proof is a one-line proof. Just try to interpret it properly. What I'll do is, if you have to prove it, what you do, you give it some charge distribution on the surface. Something is there. dq1, dq2, dq3, some charges are there. So, I mean, if you look into the current which is coming out of it, I, that should be equal to voltage upon resistance, but I should be written as J dot ds from all the elements of the surface integral of J dot ds, or just outside the surface. But J term will be sigma E. The sigma will come out. It will be E dot ds, the flux. And that flux will be the charge enclosed term upon epsilon naught. So kind of Q term upon epsilon naught. And that comes out as V upon R. Now you understand Q by V will be C. So C comes out as, and R will come here. So RC comes out as epsilon naught upon sigma, and that becomes rho epsilon naught. Obviously, this purple proof I have written for medium having epsilon naught, air or vacuum. So obviously you can change your result by this factor that we understand. So because this was directly known to a student, in the exam directly he will say that Q will be, it is a decaying RC circuit now. Initial charge is Q naught, so it is Q naught e raised to the power minus t by tau, put it tau. And now just multiply and write it down. So your answer is Q naught voltage upon distance integral of e raised to the power minus t by tau dt from 0 to infinity. It will take infinite time to disintegrate. But the distance that it will move will be finite. You can check that. Because this will become beta v dt. Now, integral v dt is the total distance it will travel in 0 to infinity time. And RHS is m dv integral, that will be 0. I mean, 0 minus 0. So, my S from 0 to infinity comes out as, it is Q naught, initial charge Q naught, into voltage upon d beta multiplied by e raised to the power minus t by tau dt. That is RC, simply. That value is tau. Tau will be replaced by RC, and RC will be replaced by rho epsilon naught epsilon. So if you look into the answer of the question, it is Q naught voltage rho epsilon naught epsilon r whole divided by d multiplied by beta. That is a correct answer. So it will take infinite time for the charge to stop. From rest state to the rest state, it will take infinite time, it will travel finite distance. And you understand, once it stops, it will stop forever because it won't have any charge. Neither it will have any speed. Now, in this problem again, he has given two charged capacitors. And there are two resistances of high resistance, different values. Question is saying, question talks about, what is the problem like? If initially both of them are given some voltages, 4 volt and 6 volt, can we find out the total heat dissipated in two resistors separately, right? In the 10 kilo ohm and the 3 kilo ohm resistors over a large time interval, the time tending to 0 to infinity. My point is, if you close the switch simultaneously, right? And this guy was having an initial voltage of 4 volt and he was having an initial voltage of 6 volts. That is it. Hello? So whatever initial energy they had was half of 1 into 4 square term and the other was having half of 2 into 6 square term. So I'm having a value of 44 microjoules. The problem in this question is we understand that at infinity both of them are fully discharged. There is no voltage, no current. The main point is, can you find out the distribution of this energy from 10 kilo ohm and 3 kilo ohm respectively? So my concern is to write the individual values. I know the total heat generated. Right? Now you have to be very careful in analyzing this problem. It is definitely not obvious, and if you observe the pattern carefully, it can be simple. Otherwise, if you start indulging yourself in writing KVL equations or trying to integrate this function, will unnecessarily create hassle. So by keen observation, there are few things we can say. Observe it carefully. Remember, I am not interested in writing the KVL equations. It will only create unnecessary panic in the problem, not required. Just observe carefully that at t is equal to 0, just observe the current in these two people. I think you know that to begin with, he was having a voltage of 6 and resistance is 3000 kilo ohm. So 2 milliampere is flowing here. And in this guy, I am having 10 volt and 10,000. So 1 milliampere. So this is 1 milliampere downwards, right? So we understand that from here, it should be 3 milliampere, which should come out. 2 milliampere goes into this. 1 milliampere flows like this. And finally, 3 milliampere comes back. This is 1 milliampere, right? So remember, this is zero situation. Now, I am just interested in zero situation to a dt situation, differential time dt after zero. I want to see what is happening at that instance. So just observe carefully that, just observe the two capacitors carefully. I think everything will be sorted. Let it be here. So just look into the charge on the upper plate or the voltage. The charge that you had written here earlier, 1 dt will be coming out of it. So initially my charge was 4 microcoulomb, right? That is 4000 millicoulomb. So I should say it is 4000, right, minus 1 dt. 1 dt. This is again in millicoulomb, no? 4000 minus 1 dt. And this guy should be second person. He was having 12 microcoulomb, right? So 12,000, this guy is 12,000 millicoulomb minus 3 dt, minus 3 dt. So I have these values in millicoulomb now, right? Now tell me, just I'm interested in this current. Now I'll use a different. This current, which was 1 milliampere, will now become what? And sustain the same units. This will be changed to, you just have to write the total voltage now, from top to bottom. And total voltage becomes, just tell me, so 4000 minus 1 dt millicoulomb, right, divided by how much? 1000 millifarad. So divided by 1000 millifarad, that is the voltage. And the second person is having a voltage of 12,000 minus 3 dt divided by 2000. That term is there. So this is the voltage and net voltage upon net resistance. So if I write 10 only here, I'll get my answer in milliampere. Ratio is constant. Similarly, if you look into this too, I'm just writing it, this will become 12,000 minus 3 dt upon 2000, right? And whole divided by 3. 10, so whole divided by 3. Now observe it carefully. Initially, it was 1 and 2. What I wanted to say is the ratio was 1:2, current here and current here. Now I've written the values after dt time interval. I check the ratio once again. It will remain 1:2 again, the initial value, or you can say the deficit value, the minus values which I'm writing there is again in the same ratio, no? Yeah? Initial is in the same ratio, the deficit in the same ratio, the final in the same ratio. Now, if that ratio is sustained, so again the difference will come in the same ratio. So again the new value will be in the same ratio. That's it now. So basically the only point was that the ratio of current in these two people will remain same. And if that is the case, and I observed this in the exam, I could have directly said that delta in H in 10 upon delta H in 3, that should be equal to is I square R term. R ratio is 10 upon 3. So I ke ratio ka square now. And what is ratio of I? 10 and 3. So it is 1 upon 2. Check. This equation is valid for every differential interval. So it is valid for delta also, delta H total. Now if you know the ratio and the sum, you'll get your answer. So main thing was to observe that the ratio remains constant. 1 dt interval was required. Right? So whenever you get such circuits, you have to be a bit careful. It's not only about writing I function always, just try to understand the pattern also in the circuit. That will help you out. The problem was such that he is talking about a sheet whose length and breadth is given. And the point is that the sheet has been divided into a grid. And the grid is somewhat like this. The grid here is somewhat like this. This is the grid, right? And in this plane of the sheet only, if I draw a line, an angle of theta and the perpendicular here, perpendicular. So you can understand that everything is happening in this grid. The grid is defined. The question kya tha? He says that for this material, when I supply, that means he generates a potential drop. He generates a potential drop across A and D. He is observing that there is a potential difference which he is applying from outside, which is 196. So 196 potential difference is generating some current in this circuit. So treat them as electrodes, and you, because of your supply of voltage, will generate some current. The matter of fact is, while you will do this across the 2 points P and Q, in the center, some voltage will be developed. The question was, what is the voltage developed between P and Q? Note, the resistivity in those two directions was different. The game is, remember, X and Y are in the plane and 90 degree, and this angle was theta. Resistivity in this direction was rho min along the x-axis. Has a maximum value and minimum value. So this is rho max, right? And this value is rho min, right? Anisotropic material. This length is given as L, and the breadth here is given as B. So take care that rho min is known, rho max is known, L is known, B is known, theta is given, V given. Can we find out Vp minus Vq? That is the question. It's a one-line problem if you observe it carefully. Observe that the point is we know the concept of current density, and here, because rho or sigma are different in different directions, so use the vector concept. I mean, use current density instead of current. It will help you out. Then write the flux. So simply what I would have done in paper is, I would have said that E in this direction is, let's say, EY, and E in this direction is, let's say, EX. So my net field along the direction VAD to VBC is EX cos theta plus EY sin theta, and this net field multiplied by distance L will provide me a voltage V. EX and EY are unknowns, don't worry. But because of EX and EY, I will have JY here and I will have a JX here. J is equal to sigma E. But whatever J I will have, they cannot have any vertical component. There is no flow of current in the vertical direction. So current density vector in the vertical direction is 0. So basically, JY sin 90 minus theta cos theta vertically upward will balance JX cos theta. Right? And you write your JY as sigma. So 1 upon rho min into EY, and write your JX as 1 upon rho max into EX. Theta is known. This is a healthy equation in EX versus EY. So your EX, EY are related by this equation. And second is this equation. Now try to understand from 1 and 2, I mean, EX and EY both are known for us now by the first equation given in second. And now the answer is this, because I know EX and EY, so if I look at Vp minus Vq, the net field in the downward direction will be EX cos sin theta in the downward direction, and in the upward direction I have EY sin 90 minus theta, that is cos theta. So multiplied by B, this is my answer. And how to eliminate EX and EY? You have two equations, two variables. It's a long expression in terms of rho min, rho max, theta, L, B, V, D, let it be. But conceptually, it's a 1 or 2 line problem. So not a big challenge, it's just a fundamental idea. Next problem. So expression you people find out, but the idea was straightforward. And again, I'll repeat, the more important thing was to begin the problem correctly. And why I got this idea was that I knew this thing, that I won't have any J in the vertical direction. But I wanted to solve in terms of E, because potential drop should be written in terms of E only. So the best idea was to take 2E in those two directions. Rest was simple. Right? So this coordinate system was helpful, but honestly, I have used a appropriate coordinate system to crack the problem. Right? Okay. Question number 51, carefully. And we can add a few questions into it. It can be a nice multi-correct problem in JEE Advanced. And we can answer it directly also, a few things. Just read it. There were these 3 plates, no gravity, uniformly spaced D, and there was a resistor R. An external agent provided the middle plate a charge capital Q first. So पहले उसने इसको capital Q provide किया. So how will it distribute? So you know that these things like Q by 2 will come here, Q by 2 will come here. Here minus Q by 2 will come. So in front plus Q by 2 here, and minus Q by 2. This was simple. No heat generated, nothing. It's like the charge is distributed. Now let us start the problem. Now he says that I will suddenly shift, and he has already said that this R is high. It's a high resistance. In presence of this high resistance, an external agent suddenly shifts this middle plate by a distance of d by 2 upwards. And his question was, how much heat will be dissipated in the resistor after this shift, after the shift, right? So again, you can solve it in two lines. There are two key things where you should not make a mistake. All of us understand that the distribution of charge will not change till the charge starts flowing. This is clear to you? A lot of electrostats idea. A lot of plates are there, and there is no wiring, no connections being done. Only individual plates are there, and there are infinite plates. Then the distribution of charge will not depend upon the distance. It will remain the same. So if I shift it by d by 2, although the energy stored will change, if the energy stored changes, then I have to exert some work. Otherwise, by zero work also I can pursue the process. But even energy is not changing because the field is same, the total volume is also same. So nothing is happening here. So I have to touch it because there is no force acting on the middle plate. Think, that's why I'm saying R is high. So if you have suddenly moved this person, because of high resistance, no charge movement has taken place. Charge will move afterwards. In terms of circuit language, let me solve the way you people want to write it. Let me write. If this was 1, this was 2, this was 3, what I'm trying to say is, you are having this capacitance between 1 and 2. Let me call it C. Let me draw it. Although you will understand that you don't need it. It is A epsilon naught by D. So, iska charge kya tha? 1 has got a charge of minus Q by 2 inside. Q by 2 is there. And 1 has got something outside also. Let it be. And then there is another 2, which has got a Q by 2, which is forming a capacitance C minus Q by 2 with 3. 3 is also having Q by 2 outside. And then there is this guy, this resistor is present here. So the circuit is like this. Now tell me, the first step, if this guy is inactive because of high resistance, and you just change their capacitances, like this capacitance C is changed to D by 2. So it is 2C, yeah? And this C is changed to 2C by 3, 2C by 3, 2C by 3. So capacitance is changed. Now the first thing that comes to mind is, in the first step, outside nothing can flow. Can there be any redistribution of charge? No. So people can say the charges will remain the same and capacitance has changed. So you can write the term of energy or whatever you want to write. Now the question will start. The question says, if you suddenly move it and now stop, then afterwards, how much heat will be generated from the resistor? That was the question. So because the charge has not changed, but the capacitance has changed, right? The new state which has been acquired is known to us. And in that state, the energy now is half of Q square into a factor of 1 upon 2C plus a factor of 1 upon 2C by 3. Yeah. Whatever, अरे भाई, जो भी आपने जाके बाहर से वर्क किया, वो वर्क की वैल्यू इस बात पे डिपेंड करेगी. प्रैक्टिकल लाइफ में तो देयर विल बी सम लॉस दैट विल टेक प्लेस, बट इन दिस प्रॉब्लम वी आर अज्यूमिंग दैट द शीट्स आर इनफाइनाइट. वी आर नॉट taking any redistribution of charge. Actually, so there will be some redistribution which will take place. There will be some charge which will flow also. But his assumption is there is no flow of charge. I'm assuming that. और एक्चुअल केस में तो ये हो नहीं सकता है कि डिस्टेंस इज चेंज एंड द चार्ज डजंट चेंज, बट यू आर अज्यूमिंग दैट इट इज इनफाइनाइट. So for any finite distance, if it is infinite, it cannot change. Think about it, otherwise the electrostatic conditions will fail. नहीं वो लिखिए कैसे, क्योंकि आप तो चेंज ही नहीं लिखने की पोजीशन में. मैं तो कहूंगा कुछ चेंज हुआ, बट चेंज कैसे लिखोगे? नहीं, वो जो भी डेफिसिट है वो सही डेफिसिट नहीं है. मतलब आप अलग से लिखना चाहते हो तो हाफ ऑफ Q by 2 का whole square था upon C का twice. So you are getting Q square by 4 times C. And this term also will get Q square by 2 and a factor of, what is that coming out as? 4 by, कितना आ रहा है ये कितना आ रहा है 4 by 2C, so that will come out as Q square by C. आ रहा है आगे ना तो Q स्क्वायर बाय C का टर्म आ गया, Q स्क्वायर बाय 4C का टर्म आ गया इनिशियली। तो जितना एजेंट ने वर्क किया वो लिखना चाहते हो तो लिख सकते हो, जिसने थोड़ा सा वर्क कर दिया होगा आके। किस पे नहीं है फोर्स, बीच में कुछ फील्ड तो आ रही है और उसके ऊपर कुछ इफेक्टिव चार्ज भी है? माइनस क्यू बाय टू विल हैव सम फील्ड हियर, वो भी नहीं आ रही। तो फिर तो जो उसके डिस्क्रीट इफेक्ट्स हैं, जो उसके एज इफेक्ट्स है, फ्रिंजिंग इफेक्ट्स हैं, उसमें सारा डिस्टर्बेंस चाहिए। मतलब ये रिजल्ट को फाइनल नहीं लिख सकते फिर। नहीं, हम उसको वहीं रहने देते हैं, प्रॉब्लम को उसके अजम्पशन पे रहने देते हैं। हम कहते हैं कि अगर आप इसका डेल्टा यू, इफ यू कैन राइट डेल्टा यू फ्रॉम सम करेक्ट मैकेनिज्म, देन ओनली आई कैन मेक द राइट स्टेटमेंट। देयर आर टू बिग अजम्पशंस व्हिच आर contemplating the problem, the big assumptions. एक तो आप मान रहे हो कि that there is no flow of charge. Secondly, also let me say, if you suddenly try to move this charge, there will be a sudden change in the distribution of charge. So the point that there is no loss will not be correct. कुछ तो होगा जिसकी वजह से सडन एनर्जी के लॉसेस तो होंगे, कुछ तो कोलिजन्स होंगे चार्जेस के बीच। So he has deliberately given that condition. So the thing is, this energy was there initially. If you assume that there is no, एक बात और भी है, मतलब ये सिर्फ नहीं कहा जा सकता कि only fringe effects are present. Internal collisions will also cause some loss, and obviously in this system energy is spread up to infinity because charges are present outside also, है ना? इस सिस्टम को जो आप बनाने की कोशिश कर रहे हो उसमें एक हैसल तो है। Otherwise, generally, when we talk about capacitors, we try to conceal the energy. We don't try to give charge on the outer surfaces so that there is the distribution of energy is at least concealed in that box, that volume, which is not the case here. So basically, we are saying the energy is infinite. You're getting the point, no? So a lot of assumption issues will be there. So that's why I'm not getting into it. So let's understand what he is trying to do first. He said कि I moved it differentially. Under the assumption there is no change in the charge distribution. So his problem starts from this point only. That's what he has said. That whatever, so t is equal to 0 plus state is your starting state for the problem. Think like that. So the question now is, after moving it in a jerking manner, whatever happens, this is the energy state. From here, things stabilize on their own. So just try to find out how much heat has been dissipated from the resistor. So after this discussion, it is simple online problem. The answer to the question which we have to find out should be this state energy, how much it comes out. It is coming out as Q square upon C. Just look into the calculations carefully. C was A epsilon naught by D minus the total final which can stay in a stable way on those capacitors. So you understand that in the final stage there won't be any current and these two will be in parallel and you have Q. So why not I write this as half of Q square upon the total C in parallel. So 2C plus 2C by 3. So let me write it as 8C by 3. Check it carefully. So, I mean, the thing is, Q square by C, which comes out as A epsilon naught by D, and then I have a factor here. So, it comes out as 1 minus 3 by 16. I mean, you can calculate the value. So, Q distribution is also not required. They will be in parallel. A total charge will be Q, and your capacitance is known, so you can directly write the energy. Just try to get into 48. And that is why I say that the language could have been even appropriate. But the concept that he has put up is nice in 48. He says gravity is absent, treat the gravity to be absent. These are the two plates with the spring connected between them in a relaxed state. Spring constant is given, relaxed length is given, and it is made up of insulating material, each plate area, mass, everything given. Now, the same idea. Treat R to have a higher value, and you provide these two people charges of plus Q and minus Q, right? And you leave them. Allow them to discharge through R. What is the total heat developed in the resistance is the first question. What is the total heat developed in the resistance? Now, the thing is, as you provided some charge, there will be attraction between the plates. The spring is getting compressed. Now, if, although he has not given, so the point is, it will take some finite time because the force between the plates is constant. So it is more of a problem of two-body oscillation. एक spring है, and there is a constant attraction force because leaking of charge will not happen as resistance is high. The force is constant. So by constant force, if you press, they will start moving in those oscillations, in two-body oscillation state. But definitely at some stage, leaking will also start. I cannot assume that they will keep on vibrating and leaking is not happening. So leaking will happen. So now there comes the thought process of the setter. Actually, what he wanted to say in this problem was, he wanted to provide it some charge, and he wanted the system to acquire a new state, equilibrium state, which it cannot acquire on its own. So either he should have said that while they were getting attracted, and the position where the net force was zero, some external agent just stopped the two plates for a moment and then left. Then it would have been a better problem. So the thing is, before he gets activated, before the charge starts getting leaked, there will be an equilibrium state if somebody stops it there. And in that state, the length between the plates will be L minus X, and the charge will be plus Q and minus Q. So in that state, you can say that the compressive spring force is getting balanced by Q square upon 2A epsilon naught. And this is Kx. That is my equation number 1. और अगर अब मैं कहता हूं कि this is the state where spring is compressed, and now you indirectly activate the resistance, because now as this stable state is being attained after charge has been provided, which will not take a lot of time because it is a two-body oscillation, so it will take some finite time, and in that finite time the loss of charge will tend to 0 because R is tending to infinity, right? So physically what he is saying is perfectly fine. The only issue is with the velocity there, right? But once it acquires this state, and if the two bodies are having nearly 0 velocity, if this starts happening, now things are very simple, because as the charge will get leaked, it will leak gradually. So the force between the plates will reduce gradually. So the spring force will also reduce gradually. So that means that compression will reduce gradually. So body will try to acquire, the spring will try to acquire a natural length state, as the force will try to acquire a 0 state, as the charge will acquire a 0 state, as the full charge will get leaked. So basically, in this case, the answer to the problem should be that whatever heat is generated should be the sum of energy stored at that instance, and I have two of them. I have half Q square, which I have provided, right, upon C, which is A epsilon naught by L minus X, and I have also a spring energy term, which is actually half Kx square at that instance. starting from that instance. And then things can fall in place properly, because this becomes q square upon 2a epsilon naught L term. And then you have two terms, minus q square x upon 2a epsilon naught and plus half k x square term. And you understand that these two terms can be calculated as kx is given. So calculate the value of x and substitute it here, you will get your final answer. Still, I say the presentation of the problem from JEE advanced perspective could be even better. Although his thought is good, but the presentation should have been even better. And I think you understand that language hassle is there even in the second part, because in second part also what he is trying to tell is, let me first tell you what is meant in the problem right now and what he wanted to say actually. Actually, if you look into the problem and somebody solves this, he will say, sir, he is saying resistance is very small and I provided charge. Initially spring was relaxed, so nothing will happen. Whatever charge I will provide, immediately it will neutralize. So the energy of the capacitor, half q square upon c, c is a epsilon naught by L, will be lost as heat. So I cannot deny that point. That can happen. Actually, it will happen. But his problem context was, so you rephrase the problem. What he wanted to say actually was, he wanted to give it some charge. He wanted it to stabilize himself. So he wanted it to stabilize itself in this state, where charge is present and appropriate compression is there. If that is the stable state, now he wanted to use the resistance. So then it is simple, because if that state is there and you use a resistance which is very, very small, immediately only the energy. So answer of this question should be half q square upon c, and c is a epsilon naught by L minus x. So the answer to this question is only this thing. This is what he wants for B part, where value of x can be substituted from this expression. That's what he. This makes sense to all of us only if the presentation is proper. So what I wanted to say is, as far as JEE is concerned, problem where he will talk about RC along with mechanics is a very highly probable question in the coming years. Right? So just be very focused about this. And there will be a impulsive phenomena also happening there accordingly. Right? If I just look into the similar problem, inductors everywhere, you should be always comfortable with. Just read up this problem. What I'll explain what I want to say. Problem will have some gadgetry, right? And look, the data is very, to begin with, seems like nothing is provided properly. Neither the capacitance is given, nor the resistance is given, neither the battery voltage is given, nothing is given. And the question is such that at t is equal to 0, somebody closes the switch and he analyzes the circuit. Then at t is equal to t, he observes that the power generated from 2R and the power generated from R, that is known 9 watt and 2 watt. So can you tell me the rate at which energy is getting stored in the capacitor? Something of that. This problem seems easy because his data has been hidden from us. But agar data deta examiner, then the problem would have been created, because answer does not depend upon that data, those values. Right? So even in inductors, while you are writing energy, just look into the parallel thing. While writing the power, what is in parallel with the inductor? Do we know the voltage from that side? Let's say, so keeping that thing into mind, if I want to write the answer for the capacitor here, what I could have done is, you want the power, na? And you know that current will be somewhere downward, here also rightward. So my point is, if this current is I1 and this is, let's say, I2, the answer to the question is simply I1 into 2R multiplied by the current here, and that current is I2 minus I1. Yeah. You know? And both the values, let's say 2R remains as such. Because those powers were given, I don't think there's a hassle. I think it should be, what is it? I1 square, 2R is 2. So I1 square is 1 by, so it is 1 by root R. So I1 comes out as 1 by root R. So I2 will come out as 2 by root R? 3 by root R. Yeah, 3 by root. Just check. So answer will come out as check. This is very simple version, but the same idea he can use in different ways. Still, it is a nice JEE advanced problem. बात समझ में आ रहा है ना? Main thing for me in this problem as a student would have been that the data for E, C and R is not given. Which way it is going to get eliminated is not important. So whenever you get such L or and JEE, when they will put up this question, they will provide all the information. So don't start solving for problems for the heck of it. Please think. In a multi-correct, he is talking about power or something. Maybe directly through some jugglery in the problem, you may get the expression. So you don't want to adopt that path where you are writing functions and you are getting the result. That is not desirable. Just be careful while solving the problems, right? The next one I'll come afterwards. Answer this question to me, 168. This is from 200 more puzzling problems. The question says ki there is a transparent black box. So this box is there, transparent black box. So you can see the internal circuit. And there are 3 resistances, X, Y, and Z inside, and 3 terminals coming out. Now a student is trying to find out the equivalent resistance about AB, BC, and CA by connecting battery and emitters. 3 बार किया उसने. So he calculated AB के cross 1, BC is 2, and AC is 3. Then he says that we understand star delta is the same. That is the reason. So if you connect it between AB, C will be open. Now Y and Z are in series, in parallel with X. You write this becomes 1 upon 1. फिर एक बार किया 1 upon 2 because this was 2. And 1 upon 3. He wrote 3 equations, he solved it, got an answer 2xy is equal to 0. Now his question is, this is impossible. He's saying this is impossible because neither x nor y is 0. So his question was, how can this mathematical contradiction be resolved? And I'm interested more into the theoretical viewpoint of the problem. Right? So if such a problem was there, the first thing that I would have thought in exam would have been, for this triangular arrangement, that is the delta, think about the star arrangement. Don't use the formula first. Think about this arrangement B, C, and A. Now tell me, when you are connecting between A and B, your answer is coming out as 1. So sum of 2 of them is 1. Sum of next 2. So 1, 2, and 3. 1, 2, and 3. अगर 3 लोगों का सम है अलग अलग कॉम्बो का, तो the possibilities are 0, 1, and 2. Yeah. So AB is coming out as 1, BC is coming out as 2, and CA is coming out as 3. So what are the values? I mean, C seems like 2. Out of A and B, take 1 and 0. So CA is 3, so 1, 0. That is it. Check. है ना? AB के बीच में 1 आ रहा होगा, ये open हो जाएगा, BC के लिए 2 आ जाएगा, this will open, CA is 3, this is, so that's fine. So when you will solve this, you understand this. Now once you understand this, if somebody knows the formula, I can convert from star to delta, I can write the values. But a better way of thinking is, if this value was 0, then the opposite guy z will tend to infinity. Basically, that is the actual problem that came here is that he is writing these equations where actually 1 upon z is actually 0, tending to 0. Z is very, very large. This guy will also tend to 0. This guy will also tend to 0. So you can check your answer for x is 1. Your answer for y is 2. And z will tend to, that is the final answer. So answer is not this. But if you start solving the equation, then you will get those weird results because you are not dealing it properly. Right? And somebody can say, is this infinity? It's not about writing it as infinite. Any value in the order is like kilo ohms, still it is working out for me. Na? So basically I can say he has connected a voltmeter here. That is also a resistance. So internal gadgetry में उसने एक जगह पर voltmeter लगा रखा है, and his resistance is actually large, and that is why this problem came. But if bluntly I solve this, I will get weird results, which is not the right idea. So you need to think properly. One more thing. So answers are fine. One more thing. If I say कि I give you 3-pin terminus, a black, this was a transparent black box. If it was not a transparent black box, and only resistances are present, and I give you 3 pins coming out of it, then I know I can convert this system into infinite combinations. That's right. But my statement is, it's fine that you can convert it into infinite, but actually the actual conversion only happens into 2 things. That is a triangular arrangement or the star arrangement. This is a separate thing, that this triangle can be further disintegrated into infinite combinations. मतलब अगर यहाँ 1 है, so I can put 1 by 2, 1 by 2 in series. I have infinite ways of representing it, further disintegrating it. But the core is always 2 things, that is star or delta. Think about it. Somebody can say, how come? Because if I have 3 points, internally I can attach, this is more likely like a Thevenin or a Norton concept, in resistors. There we talk about batteries also. Resistor ki baat kar. Because if I give you 3 pins, what best you can think of? You short all 3 of them, you close them to resistors, or some setup, but setup can be converted into 1 resistor. So then this is right. Or you start opening them. Now that is what is our star arrangement. You open AB and BC, and you try to close AC. But those combinations are already catered here, na? And all of them being attached with resistors is already catered there. So that is the only 2 combination. Anything that you are visualizing actually is a disintegration of this star or delta. So I know there are infinite possible combinations, but there are 2 core combinations theoretically, and they are getting further disintegrated. So this point you should keep in your mind while solving this problem. Right. So I'll try to finish off the class here only, and I'll see all of you on Monday with more problems. Take care. Bye-bye, students.